So we're going to take a look at quadratic equations. Now, quadratic equations are of this form. So this is a quadratic equation. It's in contrast to linear equations that are of this form. So this is your linear equation, this is your quadratic. And what we're going to be doing, we're going to be looking at different ways of solving these. And there's quite a few ways depending on how you approach the problem. So first off, we're going to look at factoring. How do you solve these by factoring? We're going to look at two factoring methods. Now, the first method I call the guess method, or guess and check. So this works when the lead term of ax squared plus bx plus c is 1. So when you have this, a is 1. So that means our quadratic looks like this. So the way this works, we're looking for two numbers that do the following. The sum of those numbers is equal to this little b. And then the product of those two numbers is equal to that little c. Now, let's do an example. So to factor this using the guess and check method, we want to make sure that we have an x squared that has a 1, or an invisible 1, as a lead coefficient, or as a coefficient. So we want to guess two numbers, a and b, that add up to -3, but multiply to -10. And if you play around with different pairs of numbers, these two numbers, actually, switch that around. These two numbers work, -5 and 2. -5 plus 2 is -3. -5 times 2, -10. So that works. A times B so that works. So we've got our two numbers. So what this means, we rewrite this as x plus a, x plus b. Or we can rewrite this as x minus 5, x plus 2 is equal to 0. So when we figure out what a and b are, capital A and capital B, we automatically rewrite our quadratic as this when we fill in the numbers. So now we're going to use something called the zero product principle. And it works like this. If m times n equals 0, then m must be 0, n must be 0, or both could be 0. Pardon me, when we get a stronger pen. The point is, anything times 0 is going to be 0. So when we take a look at this, if this is 0, then the whole thing becomes 0, which is what we want. Or if this becomes 0, then the whole thing becomes 0, again, what we want. So what would make this 0? Well, x would be 5. And for this to be 0, x would be -2. So that means our answers are -2 and 5. And that's the guess and check method. Now, another way to factor is when we have ax squared plus bx plus c, and a is not equal to 1. How do we do that? Well, we use what's called the AC method. So once again, we're going to try to think of two numbers. And we're going to do a little bit of a difference here. AC method, you could say it's named after this first move. You come up with the product of A times C. Then we look for numbers A, capital A, and capital B, where, and there's two things that A and B need to do, these capitals. A plus B is lowercase b. And A times B is equal to that product, AC. So let's do an example. Nine x squared plus 9x plus 2 equals 0. So this is little a, little b, little c. So first step, we need the product. AC equals 9 times 2, or 18. That's our first step. Step 2, first thing, we need two numbers, A plus B, that equal 9, A times B equal 18. So if we think about this, there's two numbers that work. But A equals 3 and capital B equals 6. And sure enough, A plus B is 3 plus 6, or 9, and lowercase b. And then A times B, which is 3 times 6, is 18, which equals A times C. So we have our AB. there's a third step. Now we know that our two numbers, capital A is 3 and capital B is 6. Replace the lowercase b in ax squared plus bx plus c equals 0. We're going to replace this with capital A plus capital B. So that means this equation now becomes this right here. And then what we're going to do is we'll factor by grouping. We'll factor by grouping. So it may have been a while since you've seen this, so let's go through it. We're going to distribute the x to get 9x squared plus 3x plus 6x plus 2 is equal to 0. And so what we're going to do, we're going to group a couple pairs. See, we can group this and regroup that. We're going to factor out of the two groups. So this is factoring by grouping. So what can we factor out of here? We can actually factor out of 3x. Now, what can we factor over here? We can factor 2. So what we've done by creating a group, we can call this group 1. Call this group 2. By factoring each group as much as we can, we're going to get something like this. And this is where it really comes together. 3x plus 1, 3x plus 1, they show up in the same terms, or in the same blocks here, same groups. So group 1 has a 3x plus 1. Group 2 has a 3x plus 1. Let's factor out that 3x plus 1. So we factored off this 3x, and we factored off this 2. And now we can use that zero product principle. So if this is 0, the whole thing becomes 0. That's what we want. Or if this is 0, the whole thing becomes 0, which is what we want. So let's set this equal to 0. So one answer is let x be minus 1/3. Look at this. Well, another possibility is x is minus 2/3. So our answers, minus 2/3, minus 1/3. And that's it. There's one more factoring method we're going to cover. So for this one, you do want to be kind of careful. Let's factor out an x. And it's very tempting to divide this x over here. And so we just get 5x minus 20, 0. But that's not quite right. The reason is, what if x was 0? Well, for one, if we divide x, we'd be dividing by 0, what we can't do. But if x is 0, it zeroes everything out like we want. So we can use the zero product principle, this, and with that. So first part, pretty easy. Set this equal to 0. X is 0. So that's one of our answers. Now we set this equal to 0. And divide both sides by 5. X is 4. So our answers are 0, 4, and that's it. So that's what we're looking at for factoring. Now we're going to look at square root methods. So let's go through one of these. There's different types of problems where you're going to take the square root of both sides to solve for x. You're going to take the square root on both sides of the equal sign. And oftentimes when we do this, set for maybe square root of 0, we get a plus or minus answer. So recall that if we take the square root well, there's two possible answers. Because remember what a square root is. A number times itself gives us 9. So what number times itself gives us 9? Well, one possibility is 3, because 3 times itself, 3 times 3, is 9. There's another possibility. Negative 3, because negative 3 times itself is positive 9. So when we take square roots, we have to consider there's a positive result and a negative result. So let's take a look at an example. Three x squared equals 27. First, let's divide both sides by 3. And we get x squared is equal to 9. Now, when we take the square root, we're going to take both positive, we're going to look for the positive version and the negative version. So what we'll say is x is equal to the positive or negative version of the square root of 9. Or x is plus or minus 3. So that means our answer is a set is negative 3 and 3. So that's one version of the square root. There are others. Let's take a look at this. What about this? Well, same thing, we'll take the square root of both sides. And when we do, we'll get x minus 1 on this side. Remember, we're going to consider the plus and minus versions. But we're taking the square root of a negative number. And what this means, as what we've seen in section 1.4, we're going to factor out the negative as an I, and then now we can take the square root of 9. Or 3, 5. And now we can add 1 to both sides. And that's going to be our answer. So what that's going to entail is one answer is 1 minus 3i, and the other is 1 plus 3i. And that's it. Let's take a look at another one. Let's see. Now, let's say we have this. Now, again, we're going to take the square roots of both sides. So we get 2x plus 8 equals the square root of 27. And don't forget, we're doing the plus or minus version. We got to simplify this down because 27 is not a perfect square. So we could write it like this, though. Now, what good does this do? Let me show you. If we take the square root of a times b, provided there's no negative sign in here, negative sign, we have to factor it out as an I. But we can rewrite this as square root of a, square root of b. So what this means for the square root of 9 times 3, this is why we're breaking it up this way. Let's just sort of reduce things a little bit. Square root of 9 times square root of 3. Now we know the square root is 9, that's 3. So we get 3 square root of 3. So going back up to here, we can rewrite this. 2x plus 8 equals plus or minus 3 square root of 3. In theory, you could leave it like this. This would be okay, but in the text, they want us to simplify things like this. Now we subtract 8 from both sides. And finally, we divide both sides by 2. Now remember, when we're dividing by 2, we're dividing this entire side and this entire side by 2. That means negative 8 plus or minus 3 root 3 over 2. Or if we write it as a set, there's the negative version or the minus version, and then the plus version. Again, everything divided by 2. And that's our answer. Now, one that doesn't come out quite as tricky as that. Let's say we have this. Again, we take the square root of both sides. So square root of the square, of course, that makes it cancel. 4x minus 1. And then the square root, there's two versions. We know the square root of 16 is 4, but it could also be negative 4. So this is what we get. Now we add 1 to both sides. So we get 1 plus or minus 4. Divide both sides by 4. And that's our answer. Or we can rewrite it. There's the minus version. And then there's the plus version. Now these, we can simplify. The way we can do that is just do the arithmetic. 1 minus 4 is negative 3. So minus 3/4. 1 plus 4 is 5. 5/4. And that's going to be our answer. So that's the square root method. Take a look at another one. Another one's called completing the square. Now, completing the square, it comes from an observation. Let's say we have this. If we square this, we get x plus a times x plus a. If we FOIL this, first terms of the binomials is x squared. Outer terms of the product is ax. Inner terms of the product, ax. Last terms of the binomials, a squared. So adding these together, we get ax squared plus 2ax plus a squared. So what we're going to do is make this observation. When you have a quadratic equation, this is an expression because it doesn't have an equal sign. So we'll call it a quadratic expression. If there's an equal sign, it's an equation. But when you have a quadratic expression or equation, if you have it like this, it's just equal to what we started with. Went to here, which is equal to this, which is equal to our FOIL, which was equal to that. So what we get, if we have a quadratic that's like this, we can rewrite it as that. That's all that it says. So what we're going to do, we're going to be kind of clever. We're going to take a quadratic and discover what a could be. It's going to seem kind of strange, but we'll go through it. And then add an a squared to both sides, forcing this kind of situation. Let me go through an example. So let's say we have this. X squared plus 6x equals negative 8. And we're going to complete the square. So what that means, we want to turn this into the form a squared. So we want to do that. And that means once we've turned it into this form, we can rewrite it like that. Now what happens after we do that is we're going to use the square root method from previously to solve for x. Well, this doesn't look anything like that. I mean, there's an x squared term, there's a something times x, there's not even a square term there. So what could we do? Well, what we can do is this. We could take the 6, rewrite our problem. I'm going to focus on this. Let's take the 6 and we divide it by 2. So the first step, take the number attached to the x, divide by 2. So it's going to be 6 divided by 2, and we always divide by 2. We get 3. This will be our little a. So that means we can rewrite this as x squared plus 2 times ax is minus 8. There's our little a. So you have x squared, there's the 2, and there's the a. So there we go. But now we need an a squared. So second step, we add a squared to both sides. So a squared is going to be 3 squared is equal to 9. We add that to both sides. We get x squared plus 2 times 3x plus 9 equals minus 8 plus 9. Again, what we do to one side, we're going to do to the other. Here we're just factoring, so we're not adding or subtracting, multiplying or dividing something to this entire side. We're just manipulating something. We're not changing the quantity, just making it look different. It's still equal to 6x. But now we're adding 9 here. We've got to add 9 to the other side to keep things balanced. So now, according to our rule, x squared plus 2ax plus a squared is x plus a squared. So that means with a equal to 3, here's a and here's a squared, because 3 squared is 9. We can rewrite this as x plus 3 squared equals negative 8 plus 9. And now we can just add these together. X plus 3 squared is equal to 1. So we've made progress. We've used our completing the square technique. Now we're just going to solve this using the square root. Square root both sides, so this cancels. X plus 3 is plus or minus the square root of 1. That's just 1. So x plus 3 is plus or minus 1. Subtract 3 from both sides. X is minus 3 plus or minus 1. So writing this as a set, minus 3 minus 1, minus 3 plus 1, and this here is negative 4, this is negative 2. And that's it. So for this one, you have to use 2 techniques. You gotta know how to complete the square, and then we finish everything doing the square root method. Now let's take a look at another square root method, one that's could be kind of tricky. Or square root, but complete the square. So for this one, this one looks kind of rough. So take a second to figure out how you might start this. Keep thinking about that. So any ideas yet? Well, what we can do here is we're used to working with x squared, and this being a 1, that indivisible 1. So we can divide both sides by 3. Get rid of that 3. So we're going to divide the entire side by 3, divide this by 3. So we'll get x squared, 3x squared minus 5x minus 10 over 3 equals 0. And what this does, the way it's going to get rid of that 3 is it divides into each of these. So 3, that's just 1x squared minus 5/3 x minus 10/3 x, or just 10/3, is equal to 0. So even though we got some fractions, and this looks kind of rough, let's stick to our procedure. First off, we take this minus 5/3. We divide it by 2. Which, if you remember dividing by fractions, call this 2 over 1. Minus 5/3 times 1 over 2. Remember, it's KFC. We flip, we change this to multiplication. So we get negative 5/6, and that's equal to A. So here's our A. So now we can rewrite this as x squared minus 2, or plus 2, times minus 5/6 x minus 10/3 equals 0. And as you can see, I changed this to plus. I took the minus, this was here, and took the entire minus and the 5/3 and divided that by 2. So that's what we've done here. So the minus went inside. Now we need a squared. And that's 25/36. So what we do is we add a squared to both sides. So now it's not equal to 0 anymore. It's equal to 25/36. And we're not going to combine these. We're going to keep the 25/36 with this because now this is our x squared plus 2ax plus a squared. And what we know is we can rewrite that as x plus a squared, x plus negative 5/6 squared, this whole thing. And we still have the minus 10/3 equals 25/36. And plus a negative, that's just x minus 5/6 squared minus 10/3 equals 25/36. Now, we want to use our square root property. So we need to combine this over here. So we'll add it over. X minus 5/6 squared equals 25/36 plus 10/3. And it may have been a while since you've done anything with fractions, but we want this to have the same denominator as that. So 3 times 12 gives you 36. So multiply top and bottom by 36. Oh, I'm sorry, 12. And there you go. Now, let's add these. Now we do our square root rule. So we take the square root of both sides. So the square cancels. And when we take the square root, keep in mind, when we're dealing with real numbers, that means numbers that don't have minus signs. We can rewrite it like this. So now we've got square root of 145 over 6. This is square root of 36 is 6. Now, can we do any kind of simplification here? Well, 145, let's see, it's going to be 20 plus 9, 29 times 5. And if we tried to take the square root of 29, it's a prime number. We can't. I mean, you can get a decimal, but that's it. Same thing here, prime number. There's no perfect square here. So we're not going to break this up. We're going to leave it because breaking it up is not going to do anything. So at least nothing terribly helpful. So last thing, add this to both sides. And then we can add these even again. And that's going to be our answer. Or if we put it as a set. And there we go. So that's the idea of completing the square. Let's see. Now, finally, the last thing we can do is what's called the quadratic formula. Now, the quadratic formula, if you ever find yourself in a pickle with these quadratics and you're having trouble factoring it, you're having trouble completing the square, what else? If the square root method, you need to evaluate your square because you'll have to FOIL and gather like terms. You can always use a quadratic formula. This is sort of if I'm in trouble, this is the one to go to. This one will get everything on track. So let me show you where it comes from. So what we do is we do the technique of completing the square. So we divide everything by A. We divide this by 2. and it comes out to b over 2a. Now this is the lowercase a from our technique for completing the square. Not to confuse this a with the a here. They're two different a's. So we need to square this. So let's take a look at it. Step one, we'll rewrite this as x squared plus 2 times b over 2ax plus c over a is equal to 0. And then we add this to both sides. So we add it to both sides. And this says we can rewrite it as x plus quotes a squared. Remember, that's our quotes a here. And that's this entire piece. And there we are. So we could subtract this to the other side. And we can give this the same denominator as this by multiplying top and bottom by 4a. And that's what we get. 4a times a is 4a squared. 4a times c is 4ac. Now we can combine. Twice. Now we do the square root. Square root both sides. And then we square root the top and the bottom. And then the square root of 4a squared, well, square root of 4 is 2. Square root of a squared is a. Now subtract this over. Now these have the same denominator, so that means we can combine them. And when we do, we get the familiar quadratic formula. And that's going to be what we're looking for. So to solve for x, we take ax squared plus bx plus c equals 0, and we plug in the a, we plug in the b, Just plug in the c and then simplify. So let's do an example. The key thing with this is identifying your little a, your little b, and your little c. So in this case, little a is 5. Little b is that invisible 1 coefficient. Little c is going to be -2. The negative goes along. Now, if this was minus x instead of plus x, little b would be -1. So now what we do is we take these values and plug them into our formula. So -1 plus or minus the square root of 1 squared minus 4 times 5 times -2 divided by 2 times 5. So -b, b is 1. B is 1, so b squared. 4 is always going to be there. That will always be there. Times a, which is 5, times c, which is -2. And then we have the 2, which will always be there, times a, which is 5. So this becomes -1 plus or minus the square root of 1, -4 times 5 times -2, that's plus 40 over 10. Or -1 plus or minus the square root of 41 over 10. And 41 is going to be a prime number, so it's not a perfect square, and it's not a product of any two numbers other than 41 in itself. So this is as far as we can go. So we can rewrite this as a set. -1 minus square root 41 over 10. Or -1 plus square root 41 over 10. And that's going to be it. So something to mention with this. It has to do with something called the discriminant. And this discriminant it's the square root, or what's inside the square root. B squared minus 4ac. So here's the thing. We want to see, we can tell the number of solutions, and to some extent what kind of solution, based on what this does. So let's say b squared minus 4ac is equal to 0. When it's equal to 0, this square root is 0. So we just get minus b plus or minus 0 over 2a, which is minus b over 2a, which is 1 solution. We only get 1 solution in our set instead of 2. Now let's say we have this. B squared minus 4ac is greater than 0. Well, that means we are taking the square root of a positive number. And so we get negative b plus or minus square root of a positive number. And the square root of a positive number is a real number. So we have real number plus or minus a real number divided by a real number. So we get 2 real solutions. And up here, I should say I have one real solution. But what if this is negative? Well, we're taking the square root of a negative number. That means we're going to get a complex or an imaginary number here. It's going to lead to a complex number. So we're going to get two complex solutions. So that's what the discriminant tells us. When it's equal to 0, we're going to get one real solution. When it's greater than 0, we'll get two real solutions. But if the discriminant's less than 0, we're going to be taking the square root of a negative number. We're going to get two complex solutions, or two imaginary solutions. Well, two complex. So, for example, let's take a look at some of these. So here, A is 1, B is minus 4, C is minus 5. So we have B squared minus 4AC, which will be negative 4 minus 4 times 1 times minus 5. That's got to be squared. So 16 plus 20, or 36. And this is greater than 0. So that means there are two real solutions. Take a look at another one. Now again, look for A, B, and C. A is 1, B is 1, C is 1. So computing our discriminant, we'll get 1 minus 4, which is negative 3, which is less than 0. So what that means, we have two complex solutions. Finally, let's take a look at this one. Now, again, A is 1, B is negative 6, C is 9. So we compute B squared minus 4AC, which would be negative 6 squared minus 4 times 1 times 9, or 36 minus 36, which is 0. So what this tells us is we have one real solution. And that's it. Last thing to mention is just a type of problem that comes up in the homework set. So given something like this, we want to solve for x when y is 2. So that means, first off, replace y with 2. We could subtract 2 from both sides. And there's different things we could try here. We could divide everything by 2 and try to complete the square. We can try the AC method, but I'm just going to go with the quadratic formula. So A is 2, B is minus 3, C is minus 2. So x is negative b plus or minus the square root b squared minus 4ac divided by 2a. Or negative 3. Remember, b's negative 3. This negative is always there. That's always going to be there. Our b is negative 3. So negative 3. We need a double negative. Plus or minus the square root negative 3 squared minus 4 times 2 times negative 2 divided by 2 times a, which is 2. 3 plus or minus the square root of 9. Negative and negative is positive. So it'll be 9 plus 16 divided by 4. Or 3 plus or minus 5 divided by 4. And I'm going to approach this a little differently. Again, this could be our answer. But we want to break it up into minus version and plus version. So we have 3 minus 5 over 4, 3 plus 5 over 4. This over here, negative 2 over 4, or negative 1/2. And over here, we'll have 8 over 4, or 2. So our answer as a set is minus 1/2 to. That's it. So if you have any questions about this section, let me know. Otherwise, have a wonderful evening.